Okay, today we're going to look at some equations that once again have variables on both sides of the equation, but are also going to involve some simplifying. If you look down to number 4, we got a bunch of different terms here that we're going to have to somewhat combine before we kind of fall back into the rules that we just finished talking about how we handle variables on both sides of the equation. So step number 1 for all of these is always going to be to simplify both sides of the equation. All right, so if you look at number 1, we're looking at both sides separately. 1 plus 4r is already simplified. That's a simplified expression. I can't put them together because 1 doesn't have an r and the 4 does. Same thing on the right side. This is fully simplified. So step 1 would not pertain to this question. If you look at number 2, both sides are simplified. But as we get to 3 and 4 and on, there are some things that we can simplify. So it's really important also to note that I can't simplify across the equal sign. So I can't put the 4r and the 3r together and call it 7r. Okay, I need to keep the left side separate from the right side. But if there's something on the right side that can be simplified, so if we look ahead, if I have two terms that are similar on the right side, then I can put them together, simplify. So that would be step 1. Step 2 picks right back up where we were yesterday. So eliminate one of the variables. If they're on both sides. And we talked about the best practice for that is to always eliminate the smaller one, because that's just going to give us positive numbers to deal with. Now you can eliminate the bigger one, and you can still get it right. Okay, you're just going to have to deal with negatives along the way and just make sure you don't make mistakes. So the best practice is to always eliminate the smaller number so that we just keep it positive and you're not going to make mistakes as much that way. Once you've eliminated it, you're just going to solve the equation. So the only thing different from today from what we've been doing is some of these are going to require you to simplify first. So quick review. Number 1, we've looked at ones like this. There's nothing to simplify on the left or the right. So step 1 is basically done. So step 2 is I don't want a variable on both sides. So I see r on both the right and the left side of the equal sign. One of them's got to go. Now either one can be eliminated. It doesn't matter. But best practice is to always get rid of the smaller one. So the 3 is smaller than the 4. I'm going to get rid of it. So just like if I wanted to get rid of the 8, I would minus it. That's what I'm going to do here. I'm just going to minus 3r, and that's going to make it go away because 3r minus 3r is 0. So 8 plus 0, it's basically just 8. So this is eliminated. Now I can't just randomly just take stuff away. In order to keep this equation true and equal on both sides, if I do it on the right, I got to do it on the left. So I need to do the same exact thing on this side. So as long as both sides are reduced by the same amount, it's still equal. All right, so this has gone away, leaving me just 8 on the right side. And on the left, 1 plus, 4 minus 3 is just a 1r. So I'm still going to have a plus r. And we talked about if you want to put the 1 in front of it, that's fine. But you don't have to. A 1r and an r is the same thing. Our final goal in all of these is always to isolate that variable, so get it by itself. So that means this 1 needs to go away, so I'm going to minus it on both sides, leaving me just an r equals 7. And we've already run through the checks on those, so we're not going to do that right now. Number 2, same idea, except I'm dealing with negative coefficients. So you just need to be careful. Which one's smaller, negative 8 or negative 7? It's actually the negative 8. So that's the one that I want to get rid of. And if I'm going to get rid of it, I need to get it to 0. So since this is considered a negative 8, I need to add 8x to it to cancel it. All right, if I minus an 8x, I'd get negative 16x. It wouldn't go away. So I need to add 8x to get this to a 0. I need to do the same thing on the other side of the equal sign. Now, it's going to be added to this entire side, but you want to put it directly underneath the term that it's interacting with. So I know the x and the x are going to interact, so I'm going to put it under that instead of putting it under the 9. So on the left side, I still have 1. The minus 8x is gone. On this side, nothing's going to happen to that 9. So that's still there. And I have a negative 7 plus 8. That's a positive 1, so it's a plus x, or a plus 1x, if that's what you want to write. Okay, so then I'm going to minus 9 on both sides, so that x is now completely isolated, and 1 minus 9 is negative 8. So quick review from what we were doing the last couple of days. So now as we move forward, we're trying to get to this point so then we can continue working just like we just did. But the first step is going to be to simplify so that it starts looking like questions 1 and 2. So when you look at 3, find your dividing line. Remember that you can't simplify across it. So I can't put all the p's I see in this whole problem together. Just the left side, just the right side. So the left side, 3 plus p, there's nothing I can do. That's going to stay. But the right side, there are some things I can simplify. So there's 2 terms that has a variable of p. And so that's a negative 4p plus a 6p. So if I combine those, negative 4 and 6 is a 2p, a positive 2p. Now, this negative 2 is still there. We can't forget about it. Okay, so I need to tag it on the end. Since it's negative, I can just write it as a minus 2. So step 1, simplify. Done. Step 2 now, eliminate a variable. Okay, so I've got a p on both sides of the equation. I don't want that. I want it on just one side, so it says r equals or p equals or x equals. So when I look at this, I can get rid of the p, or I can go on this side and get rid of the 2p. Either way, I'm going to get it right. Best practice, though, is to get rid of the smaller one, just to make my life easier. So I have a plus p. To get rid of a plus p, I need to minus p. And if I do it on the left side, I got to do it on the right side of the equals sign. Okay, so it's going to cancel, leaving me just a 3 on the left side, and a 2p minus a p is just a p, and I still have a minus 2. Pretty simple now. I want to get that p isolated by itself, so the minus 2's got to go away. Get it to 0, so a minus 2 and a plus 2 will give me 0. So 3 and a 2 gives me 5. And so if we were labeling all our steps, step 1 we simplified, we combined like terms. Step 2 we eliminated a variable, okay, by minusing it on both sides. And then we solved it. All right, so there's your steps written out. So let's look at number 4. On number 4, we've kind of got a lot going on both sides of the equation. So step 1, simplify. Okay, simplify. Now, here's your dividing line. So only combine things together on this side, and only combine things on this side. Don't start trying to move them back and forth. So when I look at the left side, I have a 6n and another 6n. So that gives me a 12n. And this minus 6 is still there. Notice I just stayed on the left side of the equal sign. And now I'm just going to stay on the right side of the equal sign. So I have an n, and I have an 8n. That's a 9n. I can also combine the 11 and the 7. So that's positive 18. So there we go. I've simplified both sides, fully simplified both of these expressions. So now, eliminate the variable. So I have a choice, the 12n or the 9n. Again, either way I can get it right, but if I eliminate the smaller of the two, it's going to make my life easier. So I'm going to minus the 9n from both sides. So it goes away over here, leaving me just 18. And on this side, a 12 minus a 9n gives me a 3n minus 6. So now I have a two-step equation. Looks like something I'm familiar with. All I need to do now is solve it. So get n by itself. Start with a lonely number. So plus 6. The minus 6 and the plus 6 will cancel, leaving me 3n equals 24. Divide by 3. And n equals 8. Okay. Let's take a look at 5 and 6, and on these we'll try and show a check as well. See what happens. So as I look at this, first step, simplify. And I'm not going to write these all the way down so that I have room for my check. But step 1 is simplify. And if you look at the left side, can't put anything together. So that is simplified. I can just bring it down. But on the right side, I do need to get rid of parentheses so that I have all my terms separated. So I'm going to multiply, I'm going to distribute that negative 3 to both of them. So this is negative 24n, and then a lot of people will just write plus 2. We know better, right? We're going to multiply that 2 by the negative 3. So that's going to get me a negative 6, which I write as a minus 6. All right, now I'm to step 2. Eliminate one of the two variables. Now, a lot of people, when you first look at it, you'll say 3 is smaller, but since they're both negative, negative 24 is actually smaller. So that's the one I want to get rid of. Remember that if you chose the negative 3 to get rid of, you can still get this right. It's not going to cause you to get it wrong. You're just going to be dealing with more negative numbers that way. So let's get rid of the minus 24n. So I need the opposite. So since it's a negative, I need a plus 24n. And I do the same thing on the other side of the equal sign. So I always like to start where my elimination happened. So this goes away, leaving me just negative 6, which means everything else is going to be on the left side. So negative 3 plus 24 is a 21n. And then I have a plus 36. And it's a two-step. We're going to solve it. Get n by itself, so minus 36. 21n is isolated. Combine these. Use your calculator if you need to. It's negative 42. Kind of looks like some big numbers, but when you look at 21 and 42, when I divide 42 by 21, I'm going to get 2. So this is going to be a negative 2. Okay, what does a check look like now? So the check can look a little crazy. Some of these you'll need to show a check, some of them you won't. I'll specify, but we need to be able to handle it when it's asked of us. So rewrite the original equation, and then just replace these ends with a negative 2. So it's going to say negative 3 times negative 2, because it said negative 3n, plus 36, negative 3, and then inside parentheses it's going to say 8 times negative 2, plus 2. And now we got work to do on both sides, so we can kind of do a little bit on each side as we go. So first thing on the left side I would do is multiply. So negative 3 times negative 2 is positive 6. And if you want to just go ahead and just finish it off right there, that should get me a 42. And then on this side, one step at a time, I'm going to do the inside of parentheses. So 8 times negative 2, that's negative 16. And when I add 2 to that, it's going to get me negative 14. So multiply and add inside parentheses, that gets you negative 14. And when you multiply these two together, you're going to get a positive 42. And always check that in the calculator. Make sure that this is actually what you got. All right, so real quick, pause the video and try number 6. You don't need to show a check, but try number 6, pausing the video. And then I'll come back and I'll walk you through it. So first step here is to simplify. There's nothing to do on the right side, so you should have left it alone. And on the right side, I need to distribute, but the negative 3 is going to be left alone. So I'm multiplying 8 times 4. That's a positive 32. And then don't forget the 4 times the 7x. So that's a positive 28x. Okay, simplify this side. You're going to put the negative 3 and 32 together. That's 29. And now I'm going to finish this off and show the work real quick. Okay, so once I had variables on both sides, eliminate the smaller one. So I took 6x on both sides, leaving me just a 22x over here. Negative 37 came down. And then it's a two-step. So I'm minus 29 on both sides, divided by the 22, and then I got my answer.